Today I'm going to be talking about the segment addition postulate and the distance formula. The first postulate I'm going to be talking about is the ruler postulate. Okay, and number one says find the length of a line segment BE. And line segment BE is on this number line, and it is a segment because it has two endpoints and therefore can be measured. And we call it the ruler postulate because we're going to measure it or count how long that line segment is. And the easiest way to do that is to start on the very left and count to the very right. So we're going to start at B and count 1, 2, 3, 4, 5, 6 spaces. So the measurement of line segment BE is 6 units. And if you notice the notation, I did not put a line segment or a dash above BE because the notation for the measurement of a line segment has just BE, nothing above it. So we know that that is a measurement. Okay, so make sure that that notation is correct. So for number 2, it says find the length of line segment BE. Well, if you notice, this one both has negative numbers, but you cannot have a negative for length or distance. So you will still have a positive number because we're still counting how many spaces in between B and E. So it will be a positive number. So let's start from left to right. We start at B. I'm going to count 1, 2, 3, 4. So the measurement of BE is 4 units, and that's going to be positive because length or distance is always positive, and the notation is correct because we have nothing above the BE, indicating that that's the measure of the line segment. Next up, there is a number line with several points on here, and I've given you a couple of different line segments to find the measure of. Okay, so let's start with number 1, line segment MN. So I'm going to start at M and count to N. So go 1, 2, 3. So the measurement of line segment MN is 3 units. All right, let's do the next one. Number 2 says find the measurement of line segment LN. So I'm going to start at L and go to N. 1, 2, 3, 4, 5, 6. So the measurement of LN is 6. The next one, number 3, is the measurement of KJ. Now, if you notice, KJ is moving to the left, but you can start at either point. So we're going to start with J because it's to the very left, and we count 1, 2. So KJ is 2 units. Do not make that negative because length is always positive. All right, and our very last one is JL. So we count from J to L, 1, 2, 3. So our measurement from JL is 3 units. Next up, we have the segment addition postulate. And we call it the segment addition postulate because we're adding segments together. Now, the first sentence says, if B is between A and C. So we have to make sure that we draw this correctly and we understand what between means. So if B is between A and C, that means we're going to put A first, point A, then we're going to do point B, and then point C. So in this figure, B is between A and C. It doesn't have to be exactly in the middle, it's just in between somewhere A and C. Now our postulate says if we take line segment AB, the measure of it, and we add it to the measure of BC, then we are going to get AC, which is the entire thing. So if we add AB plus BC, we get the entire segment AC. This is a part plus a part equals the whole. We use this a lot in geometry. So if we can remember part plus part equals whole, we're doing good. So we're going to use this to find number 1. It says find the measurement of DF. Well, DF is the whole thing. So what we can do is add the 2 parts together. So we can do 23 plus 35, and we get 58. So the measurement of DF is 58. Okay. For the next one, it says find GH. Now GH is a part. So we're looking for a part. So this one's a little different. I give you the whole segment, which is 36, and a part, which is 21. So if we have the whole and a part, we're going to subtract these two to get the other part. So we do 36 minus 21, which is 15. So the measurement of GH is 15. All right, so let's do two more examples on these. So number one says find the measurement of DF, and DF on this one is the whole. So we can add our two parts together, 7 plus 15, and then we get 22. So the measurement of DF is 22. And our next one, we're finding GH, and GH is a part. So if I have a whole and a part, I'm going to subtract those. So I have 42 minus 38, which gives us 4. So the measurement of GH is 4. So that's your segment addition postulate. Part plus part equals your whole. All right, next up is using the distance formula. Now I give you the distance formula, which is d equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. It's very important that we copy this down correctly. We put all the pluses and the minuses where they need to be, and we put all of our numbers where they need to be. So if I tell you to find the distance between the 2 points, I'm going to label the 2 points that I give you, which is points C and D. And remember, since this is distance, our answer is always going to be positive. Okay, so now I'm going to label, and what I mean by label is a point is always an X and a Y. So this first point is our X sub 1, Y sub 1. And our next point is X sub 2, Y sub 2. Now I label these so I can correctly plug in my numbers into the formula. So I'm going to write down my distance formula real quick. D equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. It's easier for me to plug in if I see it right there and I plug it in right below. So now I'm going to fill in my numbers. And I'm going to copy this formula exactly as I see it, just replacing with numbers. So my x sub 2 is negative 3. And then I do minus, because that's a part of the formula. And my x sub 1 is a negative 6. Don't forget to put your negative in front of that 6, because that is part of it. Then I'm going to do squared plus parentheses. Y sub 2 is 1. Then I put minus, because that's a part of the formula, y sub 1, which is 5. And then I put squared. Now I can start to simplify. Now if I look inside of here, I see a negative and a negative together. And when I have two negatives together, that becomes a positive. So I can change that into a positive. So now let's simplify inside of these parentheses. Negative 3 plus 6 is 3. So we do 3 squared plus 1 minus 5 is negative 4. And we put squared. So now we can simplify further. The square root of 3 squared, which is 9, and negative 4 squared is 16. So the square root of 25, we can simplify that into 5. So the distance, or the length, from C to D is 5 units. And it's positive, so we are good to go. All right, let's do 2 more examples for these. Okay, so for number 1, I give you points G and H. First thing we're going to do is we're going to label. So we have x sub 1, y sub 1, x sub 2, y sub 2. All right, so I'm going to write down my distance formula. The square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And now I'm going to plug in. Write my square root. My x sub 2 is 2. Then I do minus. My x sub 1 is a negative 5. And then I put squared. Plus, my y sub 2 is 6. Minus, my y sub 1 is 4. Then squared. Now I'm going to simplify. inside those parentheses. If we have a minus and a minus right next to each other, we make that a plus. So this is going to be 2 plus 5, which is 7. So we write down 7 squared plus 6 minus 4, which is 2. So we make that 2 squared. So D will equal 49 plus 4, which gives us the square root of 53. So the measure of GH is the square root of 53. There we go. All right, let's do the second one. We have x sub 1, y sub 1. We're labeling x sub 2, y sub 2. Write down the distance formula. The more times you write down the distance formula, the more familiar and the better you get at doing the distance formula. So we're going to do x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So now let's plug in. Okay, x sub 2 is negative 2. Then we always put minus. X sub 1 is 7 squared plus y sub 2 is 4. Always put a minus after that. Y sub 1 is a negative 1 squared. All right. Negative 2 minus 7 is a negative 9 squared plus a negative and a negative together make a positive. So it's 4 plus 1, so it's 5 squared. Let's bring this over here. So now we have negative 9 squared, which is 81, plus 25. So the distance between L and H is the square root of 106. And there is your distance formula.